Welcome to Code to Scale. Today, let's discuss about the 12-factor app, go through the official documentation and understand how a methodology for building software as a service looks like. So these 12 factors are kind of pretty common, but usually overlooked upon by software engineers, right? So what I thought was, why not why not go through the official documentation of all of these 12 factors and understand the significance of each one of them, and yeah, kind of go through each one of them and see what each one is addressing separately, right? Little bit of a history I wanted to kind of share was that this methodology, which is the 12 factor app, was drafted by the developers at Heroku, which is of course a famous platform as a service. I've kind of personally used Heroku during my college days to deploy test apps and everything like that. Anyways, so let's kind of, this is by the way the official documentation 12factor.net. You can go through it and kind of understand the background and introduction and each one of these 12 factors actually. Some of these pretty straightforward, and you may feel that this is pretty basic stuff. For instance, this is one Codebase track and revision control and many deploys, right? Seems pretty basic, but when we go in depth, we kind of understand that not all of these things were given, where these older senior guys who are like at the engineering leadership of these companies, right? They are kind of coming from a world where this was not the norm, right? Things were different back then, and they had to do things differently. And what we kind of take as granted is the assumption that, hey, things were always like this. Git was always there, and you could always seamlessly commit your code into your GitHub repo. But unfortunately, that was not the case always, right? So that's why these things may seem simple, straightforward, and as a first nature to a software developer now, but that was obviously not the case always, right? So anyways, I digress. Without further ado, let's get started. Okay, so we'll go through the introduction, background, and the who should read this document section, and then we'll cover each one of these 12 factors and understand what Heroku here, which is the kind of originator of 12 factor app, is trying to convey, right? Okay, so what the introduction says is, in the modern era, software is commonly delivered as a service. True, called web apps or software as a service. The 12-factor app is a methodology for building software as a service apps that uses declarative formats for setup automation to minimize time and cost for new developers joining the project. This kind of makes sense. You want to kind of minimize friction as much as possible for new developers being onboarded into a project. The more time a developer takes to get onboarded is essentially a waste of your resource. The more a new developer rather, can focus on value delivery, that's an efficient usage of resource, right? Anyways, moving on to the second point, have a clean contract with the underlying operating system, offering maximum portability between execution environment. Okay, makes sense. Apps are suitable for deployment on modern cloud platforms, obviating the need for servers and system admin. Essentially, you leave all the hard parts to cloud. This is what they're trying to say. Minimize divergence between developments and production. This is one of the most important points I want to emphasize on it, because countless number of times I've seen that there is no dev prod parity, which is one of the factors in the 12-factor app. You want to keep, I cannot emphasize this enough, you want to keep your dev or stage or UAT environment as close to production as possible. And when I say close, I mean your stage environment or your dev environment or your UAT environment should mimic production as much as it can. This, what it enables is, you can do continuous deployment for maximum agility. When you treat your stage environment as a production environment, right? By the way, there's something like there's a saying in software engineering: your services are not I think it goes like your infra is not your pet, or your service is not your pet, or something like that. Anyways, so you essentially want to enable continuous deployment for maximum agility, right? You can only achieve that when there is little to no divergence between development and production environments, right? And this will get clear when we cover all these factors. And your app is something, your software as a service app is something that can scale up without significant changes to tooling, architecture, or development practice, right? You want it seamless. Okay, let's also go through the background section as well. So the contributors to this document have been directly involved in the development and deployment of hundreds of apps, okay, and directly witnessed the development, operation, and scaling of hundreds of thousands of apps via work on the Heroku platform. This document synthesizes all of our experience and observations on a wide variety of software as a service apps in the wild. It's a triangulation on ideal practices for app development. So I think, like, if you think about it, right, the 12-factor app approach, I was kind of reading another article the other day, and it makes sense, right? If you are offering a platform as a service, you might as well tell your users, for example, Heroku, that this is the ideal way of kind of deploying your app for maximum efficiency, high availability, all the good things, right? So, and of course, in this case, all these 12 factors are of course extensible to the service that in general you're writing, deployed on cloud, high availability, scalability is taken care of, robustness, and all these things. So if I were operating a platform as a service, I kind of can get behind this idea that why not, let's kind of make a standard practice handbook and share it with everyone, and then this is how the best practices are supposed to be followed. If you want maximum efficiency on our platform, follow these sets of practices. But yeah, interesting, right? I kind of agree with this way of kind of propagating information and making your users aware that if you want maximum efficiency on our platform, you have to follow these principles. Anyways, our motivation is to raise awareness of some systemic problems we've seen in modern application development, to provide a shared vocabulary for discussing those problems, and to offer a set of broad conceptual solutions to those problems with accompanying terminology. Interesting. Format is inspired by Martin Fowler's book of Patterns of Enterprise Application Architecture and Refactoring. By the way, Martin Fowler has a couple of interesting books, and his book Microservices is something which I am reading, if I'm not wrong. Yeah, so he's one of the... Yeah, I am reading. This is the book that is mentioned in the 12-factor app. This thing, the blog 12factor.net. And where is? Anyways, there's one book on microservices, or one blog on microservices, which I regularly read. And of course, he's regarded as one of the greats in software engineering world, right? Anyways, moving on to who should read this document, who should kind of understand about 12-factor app approach. Any developer building applications which run as a service, and any ops engineer who deploys or manages such applications. All right, fine. Let's move on to the 12 factors. First one. So I'll individually go through it and kind of understand the rationale. So let's go through Codebase. What does it mean? One Codebase tracked in revision control and many deploys. So let's say if you have different environments like production, staging, dev 1, dev 2, you do not have separate repos, or you do not have like separate places where you're tracking changes for each one of these. You have one single repo where one single stable code base is there, and you deploy to multiple environments, right? That is the idea. 12-factor app is always tracked in version control systems such as Git, Mercurial, or Subversion. A copy of the revision tracking database is known as code repo. I'm sure all of you are familiar with this. A code base is a single repo or set of repos who share a root commit in a decentralized revision control system like Git. There is always a one-to-one correlation between the code base and the app. If there are multiple code bases, of course, it is not an app. It's a distributed system. Each and when things go distributed, there's a whole lot of complexity that comes along with it, right? Anyways, each component in a distributed system is an app, and each can individually comply with the 12 factor. Okay. Multiple apps sharing the same code is a violation of 12 factor. The solution here is to factor shared code into libraries, which can be included through the dependency manager. Of course, what happens is if you have duplicacy in your code and multiple apps are using it, you share that code as a library, which can be included via any dependency manager that your framework, whatever language you're using, right? So that's the general idea here. There is only one code base per app, makes sense, but there will be many deploys of the app, of course, to multiple environments, right? Deploy is a running instance of the app. This is typically a production site and one or more staging sites. Additionally, every developer has a copy of app running in their local development environment, each of which also qualifies as a deploy. Interesting. The code base is same across all deploys. I emphasize this. This is important. Although different versions may be active in each deploy. For example, a developer has some commits not yet deployed to staging. Of course, you want to dev test it. Staging has some commits not yet deployed to production. Of course, you have to QA it. But they all share the same code base, thus making them identifiable as different deploys of the same app. I think this is pretty straightforward. The whole gist of it is you maintain everything at one place, and if you have duplication, you share it via libraries, and that can be included through the dependency manager. Pretty straightforward approach, but it may seem basic, but this is one of the most important things where you have duplicacy and the same piece of code is present across, let's say, 10 or 12 or 15 or 20 repos. Instead of doing that, because it's a violation of 12 factor, what you can do is, if it's the same piece of code used in multiple places, you package it as a library and share it via dependency manager. That is how it's supposed to be, right? And it makes sense because now that library is living off as a standalone repo, I'm assuming, and you only have to maintain that. Any change in that common code block, you have to make that change in 12 different repos, instead of what you could have done is pass that as a library and made the change there, just one place. Anyways, all right, moving to point number 2, dependencies. Explicitly declare and isolate dependencies. So I have one very interesting insight into dependencies. So what happened is I typically work on trade automation and low latency, high throughput systems, primarily using Golang. What happens is you often would write tests and you mock classes, right? For mocking in Go, usually there is one library which was written by Uber. Let me just search it. Go Uber mock. Uber Go mock. And then one is by official GitHub, I think. Let me see. GitHub, Golang, Go mock. Yeah, this one. Right? So usually what would happen is between both of these two packages, one developer would have UberGo and one developer would have Golang, Golang/mock. These are, of course, incompatible with each other. And you would kind of, break your head, like, what is going on? Why is this not working? But it's just a simple package inconsistency issue. This is where dependencies come in. You explicitly declare and isolate dependency along with their versions. You tell that, okay, hey, this service is going to use these packages along with these versions, right? And you propagate that information to everyone so that everyone is aligned and everyone is using the same packages, right? Now let's go and kind of go through the paragraphs. So most programming languages offer a packaging system for distributing support libraries such as CPAN for Perl or Ruby gems for Ruby, and libraries installed through a packaging system can be installed system-wide. For example, NPM you may have used, or pip for Python, right? And libraries installed through packaging system can be installed system-wide, known as site packages, or scoped into the directory known as vendor. So if you this is very interesting. If you would have used Golang, that you sometimes do go mod vendor. This is exactly what they are talking about. Let's go mod vendor. So I mean, you can kind of go through this question as well, but this is exactly with respect to 12-factor app, right? Why this was kind of brought in. Oh, by the way, for all these commands, right? Go mod vendor. If you're into Go language, I am primarily. The best place is the official Go documentation. There's no place more beautiful when compared to the official Go documentation. Anyways, back to the 12-factor app. A 12-factor app never relies on implicit existence of system-wide packages. It declares all dependencies completely and exactly via a dependency declaration manifest. So essentially a manifest is something that you tell that, hey, these are the packages I need, these are the versions I need, and maybe these are the allowed ranges of versions that'll work for this service, right? Furthermore, it uses the dependency isolation tool during execution to ensure that no implicit dependencies leak in from the surrounding system. Isolation is important, separation of concerns is important, so this makes sense. The full and explicit dependency specification is applied uniformly to both production and development. For example, bundler for Ruby offers gem file manifest format for dependency declaration and bundle exec for dependency isolation. Interesting. So pip is used for declaration and virtual. Yeah, so if you would have used PyEnv or virtual env, you essentially do isolation using PyEnv or virtual env, and you do pip for declaration, right? Even C has autoconf and other examples. So I think the point here is clear. You have your manifest for doing the dependency declaration, and then you have another tool for doing dependency isolation as well. So yeah, makes sense. One benefit of explicit dependency. Oh my god, can't speak. One benefit of explicit dependency declaration is that it simplifies setup for developers new to the app. The new developer can check out the app's code base onto their development machine, requiring only the language runtime. And yeah, this makes sense, right? For example, if you have a Python project, what you do is you have a requirements.txt. You create a virtual environment, and then you do a pip install -r requirements.txt, right? This is exactly what this paragraph is talking about. This is explicitly dependency declaration, and any new developer onboarding onto a new project can just simply do that, right? Okay. So 12-factor apps also do not rely on implicit existence of any system tools. Examples include shelling out to image, magic, or curl. While these tools may exist on many or even most systems, there is no guarantee. So they assume the worst case scenario, that these toolings may not exist on all systems where app may run in future, or whether the version found on the future system will be compatible. If the app needs to shell out to a system tool, the tool should be vendored into the app. This makes sense. Assume the worst case scenario. Assume that the tools are not present, right? And if the app actually needs to, kind of shell out to a system tool, use a system tool, that tool should be vendored into the app, right? You should not kind of make the developer life more hard, right? Okay. Moving on to configs. So store config in the environment. pretty simple, right? I think not. So let's see what qualifies as a config, right? Before I kind of go through the entire paragraph, what qualifies as a config? You already would have kind of done this thing that, hey, let's put this in the env variables or config. But what qualifies as a config? Anything that changes between deployments or deploys or environments is something that qualifies for config. This is exactly what it says here. An app's config is everything that is likely to vary between deploys. This includes resources, handles to database, memcache, other backing services, credentials to external services, pre-deploy values such as canonical host name, essentially anything that will change. For example, you deploy your app on dev or UAT, and you know that this value is going to be different when running in production. You put it in config. Pretty straightforward. Apps sometimes store config as constant in code. This is a violation of 12-factor. I see a lot of people. I also kind of committed this mistake early on, putting API keys, committing those, hard coding these values. A bad thing to do. Anyways, I've come a long way from that. But yeah, there is of course a heaviness in my voice because of my mistakes. So this is a violation of 12 factor. This requires strict separation of config from code. Config varies substantially across deploys. Code does not. Make life simple for you. A litmus test for whether an app has all configs correctly factored out of the code is whether the code base could be made open source at any moment. This is like a beautiful line, right? And I've read this blog multiple times, and it gets me every freaking time. You wrote your code. Are your configs how they're supposed to be? Can you make your code open source? If yes, then they are. If no, then they are not. This is like amazing. Like sometimes you read these blogs and you kind of feel that this is like exactly how, if I were to kind of influence a junior engineer into, right, telling him that this is how things are supposed to be, and he would question me back that why, then I would, kind of tell him that, can you make your code open source at any moment? And he would say no. Then I'd be like, hey, yeah, this is how it's supposed to be done. Anyways, I digress. But yeah, sometimes these lines do get me. Now, note that this definition of config does not include internal application configs such as config/routes.rb. Yeah, this makes sense. This config does not vary between deploys, and so is best done in the code. Interesting. Oh, by the way, yeah, okay. Anyways, moving on. Another approach to config is the use of config files, which are not checked into revision control. So what we do in production, where I work currently, is I'm not sure if it's a best practice or not, but early on. So what early stage startup can't force everyone to kind of abide. So as a solution, what I came up with was I'll provide everyone with templates, and people via using those templates. What the template contains is that these are the environment variables or configs that your service requires. It's just a YAML file without the actual values. Now, what people do is they know that, okay, if I want to add an environment variable or a config in my service, I have to update the template. And then when they are kind of trying to deploy the app, they also have to update the GitHub, because we manage GitHub environment secrets, right? So that way, that you have a template in your service, and that, because of this template, you can track that these are the secrets that, they have to manage. But of course, this is not a foolproof or like the best solutioning. Because we use GCP, I think the ideal solution should be to use GCP Secrets Manager, something like that. But anyways, I digress. But yeah, the point is have configs. If they change between environments, the thing qualifies to be a config. Anyways, the 12-factor app stores configs in environment variables, shortened to env. Env vars are easy to change between deploys without changing any code, unlike config files. There's little chance of them being checked into a code repo accidentally, and unlike custom config files or config mechanisms, they are language and OS agnostic standard. Okay. Cool. Let's move on to backing services. So this is going to be a 3-part series where we cover 4 factors in a single short video, and yeah. So anyways, moving on to backing services. So treat backing services as attached resources. Doesn't sound straightforward from the get-go. Let's try to understand what it's trying to kind of imply. So a backing service is any service the app consumes over the network as part of its normal operation. Examples are your data store, your messaging queue, SMTP services for your outbound email, and caching systems. Now, backing services like the databases, they're traditionally managed by the same systems administrators who are deploying the app. Like an interesting thing here is, in a startup, there is no system administrator. You are the developer, you are the lead, you are the system admin. So you have to do everything. Anyways, in addition to these locally managed services, the app may also have services provided and managed by third parties. Examples include, of course, the same thing. SMTP services, metrics gathering, by the way, we use New Relic, binary asset services like S3, Blob, even API accessible consumer services like third party. You may use Maps or like Twitter or whatever. So the code for a 12-factor app makes no distinction between local and third party service. This is the whole point, right? For example, if you're spawning up a local MySQL to kind of test your service, when you're deploying it, you should be able to swap out that local MySQL without even changing your code, right? This is what it kind of implies. To the app, both are attached resources, your local and your third-party managed SQL, right? For example, RDS, Amazon RDS, and local SQL. A deploy of the 12-factor app should be able to swap out a local MySQL database with one managed by third-party, for instance RDS, without any changes to the app's code. Likewise, a local SMTP server could also be swapped out with a third-party SMTP server without code changes. In both the cases, only the resource handle and config needs to change. That's it, right? You have not made any code changes. You just change the config. Beautiful, right? Now, each distinct backing service is a resource. For example, SQL, email service, S3, Twitter, whatever. Now, for example, a SQL database is a resource. Two SQL databases would be two resources, right? And 12-factor app treats these databases as attached resources, right? Okay, now resources can be attached to and detached from deploys at will. For instance, if the app's database is misbehaving due to hardware issues, app's admin might spin up a new database restored from a recent backup, and the current production database would be detached and new database would be attached, all without any code changes. You didn't make any code changes, you just changed the config. Alright, so this is going to be it for this video covering the one-third part of 12-factor app. I'll see you in the next one. I hope this was kind of helpful and you kind of understood where this kind of 12-factor approach is coming from and what each of these 4 factors that we discussed in video mean, right? Hope you found it helpful in some way. I'll see you in the next one. Thank you.